Good afternoon, everybody. My name is Olivia Foster, and welcome to Wilt and Woodlots, What Can We Do? A webinar provided in collaboration between Bioforest, part of Lallemand Plant Care, and the Ontario Woodlot Association. Before we go any further, I'll just ask for a thumbs up from the other presenters, just to make sure that everybody can hear me okay.
I can't. Oh, yeah. I can hear you.
Yep. Okay, great. Olivia. Excellent. Okay, thanks everybody. We will move right along then. Now in today's webinar, we will be learning about oak wilt preparation, prevention, and management options for landowners. So before we begin, we'll just go over a couple housekeeping items. Now this webinar is being recorded for distribution later and will be available on both the Ontario Woodlot Association and Lallemand YouTube channel. There will be time for questions at the end of the presentation. Please submit your questions in the Q&A box just along the top there, and the moderators and presenters will answer your questions at the end. And if you see a question that you'd like to see answered throughout the presentation, you're welcome to give it a thumbs up, and those will be the questions that we prioritize at the beginning of the Q&A session. Now, before I introduce today's presenters, I would like to just share a couple words about the Ontario Woodlot Association. We are a membership-based nonprofit organization, and we wouldn't be an organization without the support of our members across Ontario. Our members are not just woodlot owners, but people who care about ensuring the sustainability of Ontario's privately owned forests. If you'd like to support our work and learn about future webinars like this one, you're welcome to head on over to our website and hit the join button and become a member for a small annual fee. The next webinar the OWA is collaborating on is the annual December Forest Seminar on December 6th from 10 a.m. to 12 p.m. with the Eastern Ontario Model Forest and Canadian Institute of Forestry Ottawa Valley section. The theme of this year's webinar is invasive species, with speakers from Canadian Forest Inspection Agency, Invasive Species Centre, and Canadian Forest Services, as well as the St. Lawrence Eastern Lake Ontario Partnership for Regional Invasive Species Management. You can sign up by visiting our website again at ontariowoodlot.com and going over to our Get Engaged and Get Involved section and scrolling through the event calendar to hit that December 6th event. Now with that, I would like to introduce our presenters for today's webinar. Now our presenters are Urban Forest Health Specialist John Barker and Alison Craig with Bioforest, which again is part of Lallemand Plant Care. And I am one of your moderators today, Olivia Foster, Communications Coordinator with the Ontario Woodlot Association. And with that, if I've covered everything, I will pass it on over to John.
Thanks so much, Olivia. Just having trouble advancing the slide here. There we go. Okay, so our agenda today, we're going to just introduce ourselves and go over our objectives for learning today. And then we're going to learn about what is oak wilt, all about oak tree biology and physiology, and then more in depth about the disease. And then finally, what can we do about it? What can we do to prevent and manage oak wilt? So Alison and I are part of Bioforest. Our urban forest health team provides forest health surveys and forest pest monitoring and management services to a range of clients, including municipalities, conservation areas, and cottage associations. Bioforest is part of the plant care division of Lallemand, a Canadian company based in Montreal. And Lallemand is an expert in yeast and bacteria manufacturing, and the plant care division is a market leader in plant bioprotection, biofertilization, and biostimulation. So I'm John Barker. I'm the Senior Urban Forest Health Specialist. I'm an ISA certified arborist, municipal specialist, and I've been trained on oak wilt in Michigan and certified by Michigan ISA in oak wilt identification and management, and also holds a Master Forest Conservation degree from University of Toronto Forestry.
And I am Allison Craig. I am currently the manager of Urban Forest Health Services at BioForest. I started with the company about 10 years ago. Before that, had professional experience in the municipal and nonprofit sectors. My work at BioForest is primarily focused on designing programs and projects for detection, monitoring, and management of invasive species in urban environments. Like John, I'm an ISA certified arborist, municipal specialist, track and oak wilt qualified, and I also completed my master's in forest conservation at the University of Toronto.
So our objectives for today, we're going to get familiar with the biology of oak trees and the oak wilt disease, and understand the impacts on trees, how the disease is transmitted. We'll look at improving our oak wilt ID skills, and then introduce prevention measures and management options. So just an overview about oaks. Oaks are mainly found in eastern Canada from about Manitoba to Nova Scotia and in BC, but also as street trees in urban areas across the country. Oaks are known to be host to over 2,000 species, including birds, fungi, lichens, mammals, and insects, and they have a vital role in the food web and help to support healthy ecosystems. Oaks can be very long-lived trees, potentially living hundreds of years, which also makes them very valuable for carbon storage and sequestration. And of course, oaks are also a valued source of timber for a wide variety of applications. So it's important to get a bit of background on oak wilt or oak tree biology, because all these concepts are going to come up a bit later. So oaks are a ring porous species. This means when the early wood forms in spring, around the time that leaves are emerging, the vessels in the vascular tissue that form are pretty large. These large white vessels here, those are the early wood vessels, and then they grow smaller as the season progresses. Only about the outer 10 to 15 rings, so about 2.5 to 5 centimeters of the wood, are living in oak trees. In white oaks, they form these things called tyloses. These are balloon-like growths that form in the vascular system that slow down the flow of water. That actually is what makes white oak particularly good for like barrel making, because it's very watertight. But these tyloses also form in new wood as a response to stress or disease infection to help block the flow of the disease. Now, it's important to note that those defense mechanisms, that tyloses formation, those are present in the stem and branches of oak trees, but not in the roots. And in the roots, oaks form root grafts. So as the roots grow and spread out underground, they often overlap and fuse together, which connects the vascular systems of different trees together, allowing them to transfer water and nutrients. Oaks can be divided into groups based on some of their physical characteristics. In Canada, we only have a couple of groups, and we're going to focus on the red oak and the white oak group in this presentation. So species in the red oak group have leaves with pointy, bristle-tipped lobes, like we see in the picture on the right here. Some of the species in this group would be like your red oak, black oak, pin oak, and species in the white oak group, like we see on the left, have leaves with rounded tips on the lobes. Species in the white oak group include white oak, bur oak, and the non-native English oak. These two groups will respond pretty differently to infection by oak wilt, as we'll see a bit later on. So about oak wilt. Oak wilt is the name that we give to the disease caused by the fungus Bretziella fagacearum. And through this section, I'll refer to the fungus or Bretziella to talk about the biology of the fungus itself and distinguish it from the disease oak wilt that it causes in the tree. So oak wilt is a vascular wilt disease. It's a destructive type of plant disease, usually caused by bacteria or fungi, and they attack the plant's water-conducting tissues and cause the leaves to discolor and wilt, and the branches and stems to die off. There's a lot of other types of these wilt diseases that affect crops and trees and other plants, like Dutch elm disease, for example, is another vascular wilt disease. We're going to get into detail about a couple of ways the fungus can spread, but basically the fungal spores are spread from a spore mat that develops under the tree's bark after it dies. The oak wilt fungus doesn't have mushroom-like fruiting bodies that we would see with a lot of other fungi. The origin of the disease is actually unknown, and we don't know when it was introduced to North America. There's some hypothesis that it may have originated in Central America because there's a lot of different oak species down there and some related species of Brachyella fungi. But the oak wilt fungus has never actually been found outside the US and Canada. There's even a hypothesis that it may be native to North America and didn't reach epidemic levels until more intensive land clearing and changes in forest management. But that theory is more discounted now. The oak wilt fungus has very limited genetic variability across its range. So that kind of points to the fact that it was probably introduced in a single location or a couple locations and spread from there. It was first identified in Wisconsin in 1942 after there were observations of rapid red oak decline and death. But it may actually have been present there as early as the 1890s, but it's not known exactly where or how it was introduced. Over the next few decades after that identification, it was confirmed across the north central and mid-Atlantic US and then continued to spread to new areas, particularly aided by human transport. Oak wilt was finally detected in Canada this year, first in Niagara Falls in June, and then quickly afterwards in Springwater, just outside Barrie, and then a month later, it was detected in Niagara-on-the-Lake. We don't know how the fungus arrived in Canada. So this is what the symptoms of oak wilt will look like. One of the most noticeable symptoms is the bronzing and wilting of foliage, which drops from the tree earlier than it normally would. Leaves on an infected tree will discolor and brown, starting at the edge of the leaf and moving inward and down towards the base of the leaf. The discoloration starts at the top of the canopy and the outer tips of branches, and it moves inward and down the tree as the crown progressively dies back. The leaves can discolor and drop through the summer as early as June, depending on when the tree was infected. And the disease progresses pretty rapidly, especially in red oak, sometimes killing a tree in only a few weeks. And the fungus also forms a spore mat under the bark, which creates a raised pressure pad that pushes out on the bark and cracks it. That's what we see in the bottom picture there. It's an exposed pressure pad and spore mat. That pressure pad is characteristic of oak wilt. No other disease causes that exact sign there. When the bark is removed, that's when you can see the pressure pad. When it's fresh, it's whitish and gray colored, and it becomes darker as it ages, eventually turning black when it's no longer viable. Those pressure pads form almost exclusively on red oaks and species in the red oak group. Very, very rarely will they form on white oaks, and they only form after the tree has died. But sometimes trees die without forming those pressure pads. For example, in hot, dry weather, the development is inhibited. So that's what oak wilt looks like. There are a number of other diseases that could be mistaken for oak wilt, so it's important to know what to look for when reporting a suspected infection. On the top left there is oak leaf blister disease. It's a very common fungal disease affecting the leaves of oak. It was very prevalent this past summer. With oak leaf blister, the leaves have these raised blisters that start out green and then darken to brown and then black. And anthracnose in the top middle is also very common, affects many other species of trees, not just oak. But the leaves get these brown or black splotches and often become disfigured and misshapen. With this and oak leaf blister, the symptoms start at the bottom of the tree, not the top like they do with oak wilt. On the top right, we have Tubercular leaf spot. This is often found on red oaks, and it occurs later in the summer. You get these round, discolored splotches that proliferate into these larger, discolored areas. Some issues with oaks are not diseases at all, but abiotic stresses caused by other agents like herbicide injury we see on the bottom right. And then on the bottom left, we have bacterial leaf scourge. This is a disease caused by bacteria. It looks a lot like oak wilt, but very important difference is between the brown discolored areas and the green areas, you have this yellow border. That border is not present with oak wilt. It just goes from brown straight to green. Trees affected by bacterial leaf scourge also tend to leaf out year after year and continue to show those symptoms rather than declining and dying rapidly like with oak wilt. Some of these conditions like anthracnose are just mainly cosmetic and don't really cause a lot of health issues for the tree. But some like bacterial leaf scourge can be chronic and potentially fatal conditions. These are just some of the more common issues. There are a number of other ones that can happen, but you may see these ones more often. So there are two main ways that the oak wilt fungus can spread, overland and below ground. And we see those illustrated in this chart here. The top shows the overland spread, which is typically accomplished by beetles called nididulid beetles. And an important factor in overland spread is human-assisted movement. This is when humans move wood that contains the Brezziella fungus into new areas that don't yet have oak wilt. And as long as that wood has about 37% moisture content or more, the fungus can survive on it. That movement can take place over large distances and across borders, allowing the disease to spread at a much higher rate and over a much greater distance than if it just spread naturally. Firewood's a major culprit in that human-assisted movement, so places like campgrounds are high-risk sites for oak wilt transmission. And just moving firewood's never a good idea from a general forest health perspective because it can move a lot of other forest pests, insects, and disease across large distances and spread infestations. I will also note oak wilt cannot be transmitted by pruning an infected tree and then pruning a healthy tree with the same tools. That does not transfer spores. But creating a wound on a healthy tree can provide an opening and an opportunity for spores to get into to the tree by the nididulid beetles. There's also no evidence to suggest that oak wilt can be spread by acorns. The fungus doesn't live in the acorns. Now on the bottom half of the picture there, we see the below ground transmission, and that occurs through those root grafts where the connections are made underground between neighboring trees' root systems. Unlike some other plant diseases, oak wilt does not spread through soil or remain in the soil after the trees have been removed. It needs the tree's living tissues to survive. But after the above ground portion of a tree dies, the roots and stump can actually remain alive for a while, even several years, 5 or more years. So if there are stumps or roots of infected trees left behind after removal, they can still be a source of fungal material. Now, many of you may be familiar with the concept of a disease triangle, where it's the concept where basically the host, the pathogen, and the environment must all be present and aligned for disease to occur. With oak wilt, an extra factor is needed, which is an entry point, whether it's an opening in the tree, like a wound or a crack or something, or a root graft that allows disease to travel from one tree to another. So we'll go into a bit more detail about those different methods of spread. Overland spread, as I mentioned, is accomplished by nididulid beetles, which we see in the bottom left photo. There are hundreds of these species of nididulid beetles. They're native to Canada and very common. About 21 of them are known to visit oaks in Ontario, and they're very small, typically only about 2 to 5 millimeters long. They actually overwinter as adults, so as soon as spring temperatures are mild enough, they're out there actively flying and searching for food sources. In Ontario, that active period is approximately March to November, although it can be affected by annual fluctuations in weather each year. The beetles are attracted to those spore mats under the bark of dead trees, which actually emit a fruity smell, sometimes compared to juicy fruit gum or apple cider vinegar. To me, the smell is very reminiscent of like overripe bananas, very sweet but kind of tangy. And so those pressure pads, as they push against the bark, cause it to crack and release that scent. The beetles are drawn in and they pick up the spores on their body. Because the host tree is dead at this point, it's relying on those beetles. The fungus is relying on those beetles to transfer spores to a new host so it can reproduce. So in the photos on the right, there's an arrow pointing to a crack, not very noticeable, could just appear like any other crack on a tree. But when you chip away the bark, you can see the pressure pad underneath. So the beetles pick up the spores, then fly to a healthy tree and can deposit those spores through any kind of opening, like another crack or a fresh wound in the bark, including pruning wounds. The risk of transmission is highest when that wound is fresh, up to about 1 week old. And it just so happens the peak periods of both nididulid activity and spore mat production overlap, so around April to July, making that the highest risk period for overland oak wilt transmission. But those beetles do continue to be active through the summer and into the fall, and spore mats and pressure pads can still be viable through that period as well. Below ground, as we said, the spread occurs through root grafts, where trees form these root connections together. The fungus can travel through roots at a rate of about 4.5 to 6.5 meters per year in loamy soil, but the below ground movement of the fungus is much faster in sandy soil, can travel up to about 13.5 meters per year, and roots also tend to graft a lot more in sandy soil. So there's much more potential for spread in sandy soil. Those root grafts usually form between trees of the same species group, like the red oaks and the white oaks, often graft together. But most of the time, trees will graft with other individuals of their own species. Usually that would be a beneficial arrangement for the trees, but the fungus capitalizes on that connection to spread and infect new trees. And in forests and urban areas where there are groups of oak trees, that can result in infection pockets, like we see in the photo here, where the disease spreads out through the roots from one infected tree to the neighbors, gradually expanding over the course of several years. So the effect that it has on the trees, once the fungus has entered the tree will respond by attempting to isolate it or heal over it to keep the rest of the tree healthy. And they do that by forming those tyloses we talked about in the beginning. The tree attempts to contain the infection by blocking the vascular system. And as it becomes blocked, it restricts the flow of water and nutrients between the roots and the leaves of the tree. And that leads to the leaf bronzing and the branch dieback, characteristic of oak wilt. Eventually, the entire crown declines and the tree dies. And this happens to young and old trees. They're equally susceptible, and healthy and stressed trees. Oak wilt will go after all of them. but the effect is different depending on which group the infected tree belongs to. So the red oak group, that's again those red oak, black oak, pin oak, and so on, those species are highly susceptible to oak wilt, and they can decline rapidly and die of the disease, often within one season, sometimes in as little as a few weeks. They simply aren't able to contain the infection, and it spreads too quickly for the tree, and it continues to block those vascular tissues. The pressure pads form almost exclusively on the species in that red oak group. The white oak group, on the other hand, and this includes white oak, swamp white oak, bur oak, and so on, those species are more successful in containing the fungus, which grows only in the outer layers of the xylem, so they're considered moderately susceptible to oak wilt. When those trees are infected, the decline can proceed more slowly and can span several years as individual branches decline and die. Some white oak trees may die after a few years of infection, but others can actually recover and heal over the infection. Bur oak, although it's in the white oak group, it's a little more susceptible to oak wilt than other species in that group, so it's kind of between the white oak and the red oak group in terms of susceptibility. It's also important to note that the timing of the infection can determine when the symptoms are visible and how the tree responds to the disease. A study in Michigan found that red oak trees that were purposely inoculated with the oak wilt fungus in spring and summer died quickly that same year. But when trees were inoculated in late summer and early fall, they died the following year. And trees that were inoculated in late fall, like in November, actually did not die at all. The fungus just simply wasn't able to take root in the tree. So now we've seen an overview of oak wilt. I'll turn it over to Allison to tell us what we can do to prevent and manage it.
Thanks, John. Just want to make sure you can hear me okay.
Yeah.
Great. All right. So like you said, now we're moving on to prevention and what we can do about oak wilt. At this point in Ontario, we only have the 3 isolated detections that John mentioned. So prevention is really our best strategy for keeping oak wilt out of our forests. The first key message here is to avoid wounding or damaging oak trees between April 1st and October 31st. This is when the beetles are most active and the trees are most vulnerable to infection, especially earlier in the season, like John just mentioned. This is the most important measure we can take to protect our trees from infection. If there's no open wound, there's no way for the disease to enter the tree from above ground. So we encourage everyone to postpone all of your oak-related maintenance to the winter months. If it's absolutely necessary to prune, maybe you have some storm damage or a hazard tree that you need to take care of, make sure to use as few cuts as possible when you're pruning and immediately cover all of the wounds with pruning paint. That way you're creating a physical barrier between the wood and any beetles that might show up with their fungal spores. After a wood is cut, it immediately starts to give off those volatile chemical compounds that beetles are really attracted to, and they move really fast to get there. They can arrive at a fresh wound within about 10 minutes, so it's important to get that paint on as quickly as you can. Normally, we wouldn't encourage this practice. It's not super common anymore to paint pruning wounds, given that there is a risk for rot. But when the choice is between rot and oak wilt, we're basically choosing the lesser of 2 evils and opting to prevent oak wilt disease. It's also important for you, if you own property, to consider other ways that trees could be damaged. For example, string trimmers around the base of your tree can do some pretty nasty damage, or mowing over exposed roots. Just that kind of routine maintenance can create the fresh wounds. Also be mindful of damage from tools and equipment involved in other operations such as harvesting, thinning, or construction. According to the Michigan Department of Natural Resources, in urban areas, most new oak wilt outbreaks can be traced back to damage from either pruning, construction, or other tree wounding activities that occurred in the spring. Our next message here, and this for many of you is probably more of a reminder rather than brand new information, but it bears repeating here because it's so critical, is do not move firewood or oak logs. Infected logs can be a source of fungal spores or of the beetle vectors, as John mentioned, and the beetles do not fly very far. So this human-assisted movement can really increase the rate of distance of oak wilt spread. This message is especially important if you own or operate a mill or a wood processing facility, or if you're located anywhere near a campground, a cottage area, basically any place where logs are being stored or where wood might be introduced from other areas. Do not cut oaks on your property and move them to another location. If you're going camping or cottaging, buy your wood locally or cut it down on site to use it. If you're buying wood from a local supplier, don't be afraid to ask where it's coming from. And don't try to judge a book by its cover. So just because you can't see any signs of the infection does not mean it's not there. It can be really tough to see those tiny beetles or the fungal spores. So those are our big don't messages, but here are some things that we can do. Do be aware, stay informed, attend trainings, workshops, webinars like this, stay up to date on the status of oak wilt in Ontario, know where the detections are in relation to your property, and educate yourself on what to look for. So CFIA, the Canadian Food Inspection Agency, and the Invasive Species Centre have developed lots of great materials, training courses, fact sheets, identification tools, things to help you get familiar with this disease. If you can, outreach and communication with neighboring landowners is great. Like other pests, oak wilt does not stop at property lines, so we can all help each other out by spreading the word. The more educated eyes out there looking, the better for everybody. Second point is do maintain an oak inventory and check your trees regularly for signs and symptoms of oak wilt. Get familiar with the oaks on your property, know where they are, how they're looking, kind of get that baseline reading, and this will help you notice any changes more readily. The best time to survey is midsummer when the changes in the foliage would be most noticeable. So you're looking for that early onset rapid leaf bronzing and leaf drop, usually happening in July when things get hot and dry. And remember with oak wilt, you're likely to see it appear in pockets of mortality and decline. It won't present as widespread damage throughout a stand. If you see that, it's more likely some kind of abiotic issue, not oak wilt. In addition to the summer, you can survey at other times of the year. Obviously, in other seasons, you won't see those foliage changes, but you can look for bark cracks on dead trees in the winter months. The next point there is encouraging species diversity. So we all know in general this is good practice in your forest stand, but specifically with regards to oak wilt, research has shown that in areas with higher species diversity, root grafting happens less frequently. So that helps to kind of disrupt the below ground pathway of spread. And then finally here, do report any suspicious trees to CFIA immediately. The quicker that we can take action, the higher chances of success with managing oak wilt and all other invasive species. So you can report a suspected oak wilt sighting online. It's easiest to just Google CFIA oak wilt report. It's very easy to find. It'll take you to CFIA's homepage, and there'll be a link there to submit your findings. The more detailed information you can provide here, the better. So obviously CFIA has had a lot of reports this year with the 3 detections that we've had in Southern Ontario. I think they said that they had over 400 reports to go through. So the more information that they have up front, the easier it is for their staff to either rule out oak wilt or prioritize sending an inspector out to the site if it looks highly suspicious. The most important information for you to provide to them is your contact information. It's important to get GPS coordinates of the tree in question, your address, the date of your finding. Capturing images of the whole tree as well as close-ups of the leaves is really great. And any historical information you can provide on tree condition. So the timing and progression of symptoms and what that looks like, that will be really helpful for the inspectors. Very important, do not collect your own samples. Just flag the tree so it's easy to find again. But CFIA staff will collect their own samples when they come to inspect the site. The reason for this is to ensure that they're getting a very high quality sample that's needed in order to get an accurate diagnosis, and obviously minimizing the wounding through the sample taking process. So do not collect samples, just report your sighting to CFIA and they'll do the collection. Okay, so now we're moving on to the management side of things. Effective oak wilt management is dependent firstly on diagnosis and then also on site characteristics. So lab confirmation is absolutely required for a definitive diagnosis. You can't just look at the tree and presume that oak wilt is present based on the signs and symptoms that you're seeing. Before proceeding with any management, a positive diagnosis is required, and that's basically so we know we're targeting the right thing, the right disease, and we're not wasting resources on potentially inappropriate treatment. So we have to have a lab diagnosis that is positive before proceeding. For regulatory purposes, all samples must be collected by CFIA and they must be processed at the plant pathology lab. Turnaround time for processing samples is about 10 to 14 days. And every site, every detection is unique. So the management approach or the plan that gets developed will depend on a bunch of different factors. The age and extent of the infestation. Is it a first-year infection? Is it a multi-year infection? How many trees are showing symptoms? As well as the site characteristics. So what's feasible given things like the infrastructure, especially in urban environments, the soil type, and the topography. So once a positive diagnosis has been confirmed and the extent of the infection has been determined, there are a couple different management options that are available for oak wilt. The first and most common one is something called root graft disruption. So this treatment involves the mechanical severing of the underground root connections in order to prevent the disease from transferring to adjacent trees through root grafting. And this is done simply by digging a trench around all of the infected and suspected infected trees. This approach is particularly suitable for multi-year, multi-tree infections. So where you have a site that a couple trees are already exhibiting signs and symptoms, you might have a dead tree or two. That's where this is going to be your preferred management approach. And the goal with this technique is to contain the movement of the pathogen and protect other healthy trees on site. In order to be most effective, the trench line must be placed properly, and there's guidelines around this placement, which I'll touch on shortly. The trench must be fully enclosed, so no open edges. It must be a full enclosed trench, and there must be it must go at least 5 feet deep. Width doesn't matter, but the depth must be at least 5 feet. The order of operations, you must install the trench before removing any infected trees, and I'll explain why in a couple of slides. And trenches are usually dug with either a vibratory plow or a mini excavator. They both have pros and cons. The mini excavator does give a slight advantage for navigating uneven or sloping terrain, but it usually does a bit more damage to the site than the plow. So while this root graft disruption is the favored management approach, obviously it's not perfect. The limitations of this method are that it cuts all the roots on site, so not just the oaks, but anything else that happens to be within the trench's path, those roots are going to get severed as well. Terrain can be tricky to navigate with this machinery, and it's crucial to know where the underground utilities are before you dig. These could, in fact, interfere with the trench placement. Like I said, especially in urban environments, this can get a little bit tricky. And then another limitation is just the nature of the equipment that's required. Expensive, it can be difficult to obtain, all these things. I've included this diagram here on the right, just to illustrate how the trench lines get placed. I won't go into a ton of detail, but I just wanted to give you a high-level overview of kind of how this process is done using something called the Brood model. Basically, this model takes the diameter breast height, or the DBH, of an infected tree, plus the DBH of the closest non-symptomatic tree, and it uses that number to calculate the minimum distance that's required between those two trees in order for us to be 95% confident they have not root grafted together. So if the non-symptomatic tree is closer to the infected tree than that minimum distance, then it's assumed these two trees have grafted, and that the disease is in their shared root system, essentially. And as a result, the non-symptomatic tree, even though it's not showing any signs yet, it would get included in the trench because we assume that it has the disease in its roots. If, however, the non-symptomatic tree is farther away from the infected tree than that minimum distance that we calculated, it's thought that their root systems have not yet grafted together, and therefore the non-symptomatic tree is considered to be salvageable. And the trench line is placed in between the infected tree and the non-symptomatic tree in order to try and save it. The minimum distance that's required for trees is slightly longer if the soil is sandy. So like John mentioned, roots graft more readily and they move more readily in sandy soil than loamy soil. So the Bruin model has two different distances depending on what soil type you have on site. And this process is essentially repeated all the way around the infected tree. Eventually, you create a trench line that encircles all infected trees and all trees that are likely to be root grafted with those infected trees. An alternative to root graft disruption is something called root plate excavation, which basically involves using an excavator to rip out the stump and the associated root mass. So this breaks those grafts and it kills the root system, and then the fungus has nowhere to go. So this management option is really only suitable when the infested area is very small. We're looking at possibly only a single tree infection. Maybe you're seeing some wilting in the canopy, but the tree is still alive. So it's considered to be a first-year infection. And as such, we expect that the infection has not yet entered the root system. So therefore, our goal here is to remove the tree before the fungus gets into the root system. In order for this strategy to be effective, the tree and the root plate must be removed in the same day together. When the above ground portion of a tree is removed, the fungus almost gets pushed down into the root system. So we want to avoid this happening by killing the above ground and below ground parts in the same day. In the United States, this procedure is being used and it has a very high success rate, between 90 to 100% effectiveness in stopping the spread of the pathogen. Again, there's a few limitations here. Larger trees obviously require more resources to remove in this manner. The equipment, again, can be costly, and full extraction of the root system is necessary in order to remove all of that living tissue. Okay, so now we'll talk about some guidelines related to tree removal and proper disposal. So I touched on this earlier. The order of operations with respect to tree removal is to protect the other trees on site, either by trenching or treating them. And we'll talk about treating in just a minute, prior to removing any infected trees. And the reason for this is that cutting that infected tree speeds up the uptake of the fungus into the surrounding oaks that have shared roots. When the vascular system of the cut tree is gone, it's no longer creating that upward pull, that translocation from its root system. So the surrounding trees that have shared roots can pull resources from that cut tree's root system more easily. We don't want to create that scenario. So we want to remove or treat the trees or trench around them before we remove them. And the state of the tree will determine at what point in the year it gets removed. So a tree that's found to be dead with fungal masses present, like the ones that were found in the Niagara Falls detection, the first detection in Ontario, these trees need to be removed immediately, and that's in order to prevent the spread of those fungal spores. If a tree is infected, but it still is living, it's only showing those leaf symptoms, like the trees found in Springwater and I believe Niagara-on-the-Lake as well. These trees are removed later in the season after the risk period has ended because they're not a source of active fungal spores. So it's not as important to remove them right away, but they do have to be removed prior to the high risk period the following year. After the trees are cut down and removed, they must be disposed of properly. So the fungus, like John mentioned, is not able to survive in wood with low moisture content. So ideally less than 20%, but 37% moisture content is generally kind of the benchmark. Basically, we're looking at any option that dries out the wood and thus kills the fungus. So burning the wood, burying it underground, or logs can be processed into firewood and covered with a tarp on site. They're left to dry out. All of these options are viable as long as we are drying out the wood. Okay, now on to chemical treatments. So currently in the United States, they are using two different chemical treatments in oak wilt management. They're fungostats and herbicides. So we'll start with the fungostat, and the active ingredient here is called propiconazole. The goal with using this product is to preserve an individual tree by halting the fungus in the water conducting vessels and keeping those vessels open and functioning. It does not eliminate the fungus from an already infected tree, nor does it prevent the fungus from spreading to other trees. It just inhibits the growth of the disease within that individually treated tree, slowing down symptom development and reducing tree mortality. It cannot be used as a substitution for root disruption, and usually it's used in conjunction with other management strategies. It's not really intended to be used on its own. The product in the US that is most commonly used is, like I said, a propiconazole with the trade name Alamo. It's a liquid formulation. It's injected directly into the xylem of the tree using a macro infusion system. So it's a lot like the treatment for Dutch elm disease, if anybody's familiar with that. As far as limitations go, it does degrade. It doesn't last forever. And since oak wilt can live in the root system, like John said, for 5 or maybe even more years, the tree must be re-injected every 2 years in order to maintain disease suppression. Once the tree is injected, the product doesn't move very far. It doesn't move up into the canopy. Mostly it stays within about a meter of the injection site. So it's pretty limited translocation. And for that reason, it has not been proven to prevent above ground transmission. So it's really only warranted for trees that are threatened by root graft transmission. For red oaks, it is only preventative. It cannot reverse symptoms that are already present before treatment. For white oaks, you can apply it therapeutically, but only if there is less than 30% canopy loss. All of that being said, currently there are no fungostats or no fungicides registered for use against oak wilt in Canada. Those discussions are ongoing, but there's nothing currently on the market for us. Next, we're going to talk about herbicides. These are just starting to be used in the US kind of experimentally in oak wilt management. The results so far are a bit mixed, but research is ongoing and it's actually quite promising in certain circumstances. So the goal with this management tool is to prevent the fungus from getting into the root system, and it does that by killing the host and stopping disease transmission that way. The active ingredients that they're trialing in the States are triclopyr, imazapyr, and glyphosate. And they're using this method when an individual tree or a very small pocket of trees is found to be infected. The trees are girdled, the herbicide is applied to the girdling wound, and then the trees are left in place for 6 to 8 weeks. In that time, they die and dry out, so they won't be producing pressure pads, and then they are removed. So the idea with this is that this operation is cheaper, it's less work, and less specialized equipment is required than something like root plate extraction. However, obviously it has its limitations as well. As I mentioned, it's still experimental. There is limited replicated research. Currently, trials are ongoing, but they do need more information on things like application timing, active ingredients, how quickly it kills the root system, things like this, before it can become a solid management recommendation. And as a result, there's no kind of standardized protocol for this yet. In addition to that, leaving dead standing trees on site might not be feasible in all situations, obviously from a risk management perspective. And finally, it does involve the use of chemicals. So there is the consideration of using these products in your woodlot and what that means for you. Similar to fungostats, it's typically not the first choice of treatment, and it's usually only used selectively in conjunction with other tools, but it could be useful in situations where the terrain is difficult for machines to access or where infrastructure might severely limit the effectiveness of something like root disruption. Like I said, right now, this tool is not included in Canada's oak wilt response framework, but it's something that's worth keeping our eyes on. Finally, in the management process, this brings us to our final step, but I also kind of consider this the first step, and that's monitoring. Like I mentioned, proactive monitoring is one of the best ways we can be prepared to respond to oak wilt. And by detecting it as early as possible, this gives us the best chance at containment and eventual eradication. So in the case where a detection has been made and active management has taken place, like in the 3 detections made in Ontario this past summer, there must be ongoing monitoring in order to detect any resurgence of the disease. And 5 years of negative survey data is required in order to declare oak wilt eradicated from that site. So CFI is currently doing those surveys, and they will continue to do those surveys for the next 5 years around those 3 detection sites. Okay, we're wrapping up here. That was a lot of information that we threw at you. So we wanted to just summarize with some key takeaway messages that we hope you'll remember from this presentation. Oak wilt is largely preventable. This is the first one. If we follow the prevention measures that I outlined earlier and remember that disease triangle that John mentioned, with the additional element, not only do we need the host, the pathogen, and the right environmental conditions for oak wilt to flourish, we also need that entry point of a fresh wound, a bark crack, or a root graft. So without that, we don't have oak wilt, and that's why prevention is so important. Naturally, this is a very slow moving disease. Management is possible as long as it's done effectively and thoughtfully. However, human assisted movement can really increase the rate and disease of spread. Visual monitoring is key to early detection. And finally, reporting any suspicious finds to CFIA immediately for rapid response is crucial.
And thank you, Allison and John and Bioforce, for sharing your knowledge with everyone today. We've all heard that knowledge is power, and I trust that landowners and others on the call today have more information to prepare and prevent oak wilt, and also manage oak wilt with the help of professionals if there is a positive diagnosis. So thank you again, and we hope that you all enjoyed the presentation today, and thanks for joining us on your lunch hour.